Hi, in this video I'm going to explain about Spring Transactional Management, how it works with proxy-based approach. In this video I'm not going to explain about Spring Transactional Manager or different types of transactions that we use, different types of transactional managers. I'll be focusing mainly on how Spring Transaction works with proxy-based approach. If we can understand this approach, then it is very easy to understand how Spring Transactional Propagation behaves. I'll explain what is Spring Transaction Propagation also, but I will not go into all types of Spring Transaction Propagation. I will focus only that is related to this concept. Before going into the actual Spring Transactional mode, so let me explain about what is proxy. Proxy is actually it is a very simple design pattern and well-versed design pattern. Knowingly or unknowingly, we are using this proxy design pattern in many ways in our real-time applications. So proxy, we can say it is a replica to our original object. Proxy, the usefulness of proxy is used in many ways. Mainly the proxy can be used to reduce the what we say memory footprint of the real object. Say for example, a real object has to be loaded from somewhere from the network. So instead of that, I can create a mock object or a proxy object and serve the request from the client. So client will think that it is talking to the actual object, but it is a proxy object which is having very low memory footprint, and then the proxy then intercepts those requests and then delegate the request only when required to the actual object. Otherwise, whatever proxy, if it can serve the request and response, so proxy can serve that. So that is one of the usefulness of proxy. Another use is, for example, say I have an actual object. Mainly proxy is used in aspect-oriented programming. For example, I have an actual object, and mainly I have to apply cross consents for this object, or cross consents. What are cross consents means? Say the stuff which is not the actual business logic. That means, say I want to apply some loggers, or I want to apply some security, or I want to apply transactions. Okay, so everything are all cross consents. So these cross consents, say this is my actual object. So this is my actual object. Now, if I want to apply some cross consents, that means the stuff which is not a business logic, like logging or something, or logging or transactions or security. So I need not apply in the actual object. Now what I can do is I can create a replica of this object. So that means a replica of this object. So any object, this is what we call it as proxy object. I will name it as proxy object. I will name it as proxy object. Now what this proxy object will do is, now request that is coming from client, request that is coming from client, request that is coming from client will first be intercepted by this proxy object, and then that request will be transferred to the actual object if needed. Say for example, I want to actually access this actual object. Now my proxy object, before invoking the actual object, this client request will be intercepted with this proxy object, and then before calling the actual business logic, so this proxy object, what it will do is it can validate that request, and if that request is valid or not, if it is valid only, then it will actually call the business logic of this actual object. Otherwise, it will return the response. This proxy object itself returns a response that this request is not valid. In this way, proxy object can even act as a filter. We can say this is one of the filter mechanism. So in this way, or say for example, I want to apply some logging to this logger methods, logging statements. So what I can do is, in the actual object I can write the business logic, and I want to apply logging before the start of the business method and end of the business method. Then instead of writing the loggers in the actual object, what I can do is in proxy object, I can, before calling the actual object method, I can write here a logger statement in the proxy object. And then from the proxy object, I can call the business method of the actual object. And then after that, after calling the actual object business method, then again, I can write a logger in the proxy object. It is like as if like this. Let me write you this. Say logger.info, something like that. Okay, I can say business method called start or something like that. And then I can call the actual object dot business method. And then I can say logger.info of business method end. Business method end. Okay, I can say like this. So this proxy object in the logger info, the logger logic is written in the proxy object, and then the actual object business method is called, and then the logger business method ends here. So in this way, my proxy can intercept any client request. So before calling the actual object. Now with the same concept, now we are going to deal with how Spring transaction works. So Spring transactional. So any Spring Bean method with annotated with transactional is intercepted by proxies. This is very important statement, is intercepted by proxies. So Spring Bean method with a transactional, annotated with transactional, is intercepted by proxies. So in this video, we are going to see mainly on this concept. So this type of transaction, we call it as a declarative transaction, and we have another method called programmatic transaction. So I'm not going to deal with those type of mechanisms in this video. So I'm going to deal mainly with this concept. Spring Bean method with @transactional is intercepted by proxies. So this is the main thing I'm going to deal with. So this proxy can be a JDK proxy or CGLib proxy. So in this video, again, I'm not going to deal about what is the difference between JDK proxy or a CGLib proxy, but CGLib proxy is a third-party proxy and JDK proxy is the dynamic proxy that is being provided by Java. Okay. So let me study this concept with an example so that you will be clear about how this mechanism works. So I have a client program, and this client program will I have a client program which is a main program. So I'm declaring I'm creating a Maven project initially. So in this Maven project, I'm creating all the libraries, whatever the dependencies that I have, I am including related to Spring framework. And what I'm doing here is I'm creating a client program first. So in this client program, what I'm doing is I'm calling a department service. So basically, this client program will call the department service, and department service has a method called create department. It will create the department data, and internally this create department will again call a method called create employee. Okay, so what I'm doing is I'm having a service class which is department service. In the department service, I have a method called create department. So I'm creating a department I'm creating a department with the department data. So from this department data, then I'm creating an employee data. Okay. Remember, this create department is the parent method and create employee is a child method. That means this is the outer method and this is the inner method. Okay, and this is the Spring Bean. Okay, as of now, remember this is the outer method. So create department is the method that is called from the main service, and internally this service will again call create employee method. This is the inner method. Okay, so that means here I have two model objects, one with department department data that is stored in my department table, and I have one more data that is employee data that is stored in my employee table. Okay, simple. So in department I'm storing the properties called name and id. Id is auto generated and it is a department name, and in employee also the employee id is auto generated and I'm storing the employee id is auto generated and I'm storing the name. So for that I have the associated tables also. I'll show you the tables. So this is my department and this is my employee. I'm just storing name and ID of the employee, and similarly I'm creating the name and ID of my employee, and here in my department I'm creating name and ID of my department, and the primary key is ID, which is auto generated. Okay. Now what I'm doing is from my main class I am creating the department, and department internally creates the employee. That is the higher view. So my client program, which is called main program, will create a department, and department internally creates employee. So that means department will first get created, and then department internally creates employee. So that means department is my outer beam and employee is my inner beam. Okay, remember like that. So this is my example. So in this, how we are using the transactions and how the transaction propagation takes place, we'll see now. So I'm creating model classes. So this is annotated with the JPA annotations with entity and table name. These are all actually, I'm not going again in depth of this JPA annotations. Similarly, employee also with JPA annotations with entity, with other rate entity, and employee is associated with my employee table, and the ID is an auto generated ID. Now if we see here, create department is the method that is being called from the client program, that is main program. Now in this create department, I am actually doing like this, @transactional propagation dot required. So as I told, whenever we are using Spring Bean @transactional, so that means what will happen is, as I told, so this is intercepted by proxies. This is intercepted by proxies. So whenever department service is a Spring Bean. Why it is a Spring Bean? Because I am declaring department service in Spring Bean configuration. Okay, so it is a Spring Bean. So whenever any Spring Bean method associated with @transactional annotation, that means this is intercepted by proxy. And here we have propagations. So propagation dot required. So transactionals, we have several propagations. Okay, I'm not going to tell about all the propagations, but whatever required right now, I will tell now. So what you mean by propagation dot required is, basically what is the concept of transactional propagation is, say now this is the method that starts with some transaction. Now this method is calling another method called create employee. So that means this method has started one transaction, and transaction propagation determines that whether the same transaction has to be used in create employee method, which is the inner method of this parent method, or whether a new transaction has to be instantiated like that. So it determines the propagation behavior. That means whether the parent transaction, whether the transaction that is started in the create department method has to be propagated to this create employee method, or any new transaction has to be. So it determines the propagation behavior between the outer methods to the inner methods. Okay, so this is what actually transactional propagation, and the default is propagation dot required. Okay, if I don't specify any propagation, it is a propagation dot required. Now right now what this means is, now if I am telling propagation dot required means, So transactional by default. So this transaction will be propagated to this transaction to create employee. Now if I see create employee method, here I am using propagation dot requires new. So what this means is, so requires new means that means this method will start a new transaction, and the parent transaction which is started at create department, that gets paused, that gets stopped temporarily. So till this create employee method is invoked, the parent transaction, that is a transaction that is started at create department, gets stopped temporarily, and this create employee will use a new transaction. Now suppose if I don't specify anything here, if I don't specify any propagation here, if I specify only just at the rate transactional, and if I don't specify anything here, that means the default is required. So if I don't specify anything here, and if I have only like this, that's all. And if I have only like this, if I have only like this, so that means default is required. That means whatever the transaction that is started at create department, the same transaction is propagated to create employee, and create employee also uses the same transaction as of the parent transaction. That is here the parent transaction is outer transaction, which is the department, the transaction that is started at create department. This is what propagation, but there are other types of transaction propagations. We are not going to deal right now. Let us focus only on how this proxy based approach works with transactional model. Okay, now as I told, any spring bean method that is annotated with a transaction that is intercepted by a proxy. Now what will happen is, now my client program is calling create department of department service. What will happen internally is, there will be a proxy class created on this department service. That means my client program, programmatically this client is calling department service, but internally a proxy is created in between the client and the department service. So assume that the name is department service proxy. Assume that the name is department service proxy. And any, as I told, proxy class is the replica of the parent of the actual object. So replica means generally it should extend the features of the parent of the original object. So that means department service proxy extends the department service. So that means a proxy class is a child class. Here the proxy class is the child class of the actual object. Now the method, the same method, say client is calling create department method of the actual object. Now the same method replica, with the same method name and the same method arguments, the replica method is created here. That means the method is overridden here, because this proxy class is the child class of the actual object. Now here if you see, whenever @transaction is applied, so a proxy class is created here, and here a transaction logic is applied here. This is our traditional transaction, how we use. Now we are using @transaction, but earlier we used to use either in actually when we go for a J2E model where we use EJP transactions or on user context. So we use these type of transactions in programming, in bean managed transactions earlier. So generally this is being provided by an entity manager right now. So entity manager begin, that means the transaction starts right now. And once transaction is started here I'm calling super.create department. So now it will call the actual business logic of the super class. So that means, so my transaction starts, the first line transaction starts with a begin statement, and then the super class method, the super class is the actual object which is department service. That business logic is called here, which is create department method. And once this business logic method gets executed, then here the transaction logic again is applied on the proxy. Remember, the transaction logic is not applied on the actual object. The transaction logic is applied only on the proxy. So what is your transaction logic? That is get transaction not begin, get transaction not commit. So this is your transaction logics. So on these transaction logics, so in between these begin and commit, your business logic is called. How it is called? It is called using super.create department. The super is the super class of this, because the proxy is the child of this parent class, the actual class. Okay. So in this way, the proxy intercepts the request, applies the transaction. The transaction logic is applied on the proxy, then calls the superclass business method, and then ends the transaction. In this way, uh, the flow takes place. Okay. Now, now the question is, say I have department service. In this department service, I have the create department. In this create department, as I told, there is another inner method called create employee. Now this create employee is called from the same department service. Say for example, so this create employee, the implementation of this create employee is in the same department service. This create employee is called from the department service. Now how the transaction behaves in this scenario, we'll see. As I told, transaction is applied only on the proxy, not on the actual object. So now whenever the client calls department, create department of the transactional method, then a proxy is created and first the transaction is beginned, then it will call the superclass of the uh, parent class. Here super.create department is called, and in create department, now I'm calling create employee. So now create employee is treated as the local object here, because here this is not intercepted by proxy, remember, because once super.create department is called, now create department is the parent class. It is the parent method. It is a superclass parent method. So in this parent method, create employee is called. Now say for example, this create employee is annotated with transactional. Say create employee is annotated with transactional here, like this. Create employee is annotated with transactional like this. Create employee is annotated with transactional like this. Like this, create employee is annotated with transactional. Though you apply transactional or not, the proxy will not intercept this. Remember, this is very, very important. The proxy will not intercept this @transactional because this method is called from the same class. This method is called from the same class. So if you see here, so this method create employee belongs to the actual object. So now create department will call create employee. Create employee is called from the same class. So proxy cannot intercept this one. So if proxy cannot intercept create employee method, why proxy cannot intercept create employee method? Because create employee is called from the create department method of the superclass object. So proxy cannot intercept this create employee method. If proxy cannot intercept this create employee method, then transactional logic will not be applied on this create employee method. Transactional logic is applied only on a method where proxy can intercept. So transactional logic is applied on create department because proxy is intercepting this. But create employee is called internally from create department, and this create department belongs, and this create department is the superclass method here. So now proxy cannot intercept this request because internally this is being called from the parent class itself. So that's why proxy cannot intercept this request. So that's why transactional, though you put @transaction or though you do not put @transaction, transaction will not be intercepted here. Now, what if I want this create employee also to be in transactional? See, by default, whatever create department is there and create employee uses the same transaction because it calls internally. But what if I want create employee to be used to undergo a new transaction? That means create department should be in one transaction and create employee should be in another transaction. So for that, what I'll do is I will create one more spring bean, just like how I created department service. I create one more class called employee service. Employee service is also spring bean. In employee service, I just say transactional propagation dot requires new. Now what will happen now? We'll see now. Now if you see here, now any client request will be implemented by proxy. Now the transactional logic starts here. Then it will call super.create department. Now in super.create department, this will call this method. Okay, actually this arrow should be from here. Super.create department will call this department service create department method. In create department method, now you see here, Now here I'm calling employee service dot create employee. Now when I say employee service dot create employee, this is a separate class. This is a separate Spring Bean. So now, just like how when client is calling department service, a proxy is created. Now here department service is calling employee service create employee method. Now for employee service, there will be a proxy created right now. Because create employee is associated with the transactional method. Any transaction, any Spring Bean method associated with @ transaction is intercepted by a proxy. Now employee service dot create employee. Now employee, whenever this statement gets, now a proxy is, now this call will go through a proxy. Now it will not call the actual object. So now this proxy again it will create a method, use the same method create employee. Again this employee service proxy again extends employee service method. In this create employee method, there will be a transaction logic to start transaction, and it will call the super dot create employee. Now this will call the super class method of employee method, and there will be an end to transaction logic which ends the transaction. Okay. Now what will happen is, now since I am calling the create employee method from another Spring Bean, now the transaction is intercepted. Now the transaction is why means a proxy is created right now. Now whenever a proxy is created, the transaction logic is placed on that proxy, and then it will call the superclass business method and then ends the transaction. So it will start the transaction, superclass business method is called, then ends the transaction. So in this way create employee transaction method is intercepted. Now since the transaction is intercepted, now the propagation right now it works. So whatever propagation we put, whether it is a requires new or whether it is a required, so now the propagation behaves because the transaction is intercepted right now. Now whenever I say dot requires a new, so what will happen? So create department will undergo in one transaction, and create employee will undergo in another transaction, in new transaction. Okay. Now for example, if I don't specify anything, or if I just specify required, that's all. If I just specify required, then what will happen? Create department and create employee will undergo in the same transaction. Okay. So let me actually explain what is the what will happen if both methods undergo in same transaction. What will happen if both methods undergo in different transaction? Say create department method uses transaction A, and create my employee method uses transaction B. Because why means in create employee I am using transaction propagation as requires new. Okay, if I am using requires new. So this create employee method uses a new transaction, create department uses transaction A, and this uses transaction B. Now what will happen? Now client will invoke the method. Okay, create department uses transaction A. Now create department will call create employee method internally. Create employee method uses transaction B. Now both methods are using different transactions. Now if there is an exception in create employee method, if there is an exception here in create employee method, and what will happen if there is an exception here? If the exception is thrown back, again if the exception is thrown back from create employee method, then what will happen is create department, if create department catches that exception, if create department catches the exception thrown by create employee method, then what will happen is only the create employee transaction gets rolled back, because create department transaction will not roll back because both are in different transactions. That means employee data will not be saved, but department data will be saved, unless and until if create department internally generate its own exception. Otherwise create department will not roll back with the exception that is generated from create employee, because both are in same transaction, both are in different transactions, both uses different transactions. Okay. Now if create department and create employee uses the same transaction, what will happen is, now if create employee throws the exception, now since create employee throws the exception, automatically this transaction is set to roll back because both uses the same transaction. Automatically department also uses the same transaction, so department also gets rolled back. Okay, so whenever, remember two things, whenever a method throws an exception, that means the transaction is set to roll back. Whenever a method handles that exception, then the transaction is not set to roll back. So remember that point. If, say for example, in create employee itself, if I can catch the exception, say for example, here, let me actually show you here. Here, I'm just creating an employee. I'm using a Hibernate code here. So department.create, I'm just saving the department. I'm just saving the employee here with the Hibernate session factory. Now here, what will happen is, now I say department DAO dot create employee of employee, and I'm generating an exception. That means I'm just dividing by 0. I want to simulate some exception, so I'm just dividing by 0 so that I get an arithmetic exception. Now what will happen is, now here I'm just calling department service. Let me execute this flow. Let me actually let me drop the tables. Let me create the tables again from beginning. Okay, and show you the data. So show you the data, then I'll just select this data and select this data. Okay, now what will happen is, now this will call the department service. Okay, in department service, I'm just putting transaction data. I'm just setting some employee data here because that has to be passed to create employee method. And here I'm first creating the department, then I'm calling employee service dot create employee. Okay, so whenever I say employee service dot create employee, so it will go to the employee service dot create employee, and here it will create the employee, and here I'm just generating some exception. So I'm not catching here the exception. So that means this method will throw runtime exception. So that exception will come to here, and here I'm catching the exception. Okay, so here I'm catching the exception. Now what will happen? So this is using one transaction because it is using it is starting a required propagation. Here it is starting requires new. That means this is using another transaction. So whenever this method is throwing an exception, so that means this transaction is set to be rolled back. This transaction is set to be rolled back, and this exception is coming to the catch block here. That means I'm catching this exception. And since this is using different transaction, so this transaction will not get rolled back unless and until the other part of the code, that means the code which is not related to create employee, if other part of the code throws the exception, then this method transaction is not set to roll back. Remember, this method is not set to roll back. If I'm catching the exception, any exception, if I'm catching in the create department, that means if I'm not throwing the exception outside this method, then the transaction is not set to roll back. Remember, if I'm catching the exception internally in the method itself and I'm not throwing the exception outside the method, so that means the transaction is not set to roll back for any method. If I'm throwing the exception outside the method, so that means this transaction is set to roll back. Now we'll see different scenarios like this. So now what will happen? Now I'm passing department 1 and I'm just throwing the exception outside this method. So that means definitely this transaction is set to roll back. So that means the employee will not be saved. It will get rolled back. But since it is a new transaction, so this transaction and this transaction are independent. And here this exception I'm catching here itself. So that means I'm not throwing again the exception out of this method. So that means this transaction does not get rolled back. So let me show you this. Let me run this program. And show you. Run as Java application. If you see here, now I'll see select star from my department. So I'm getting department stored, but I will not get employee because employee is rolled back. See, I'm not getting anything because the employee transaction is rolled back because both are running in different transactions. Now, okay, let me delete the data. Let me delete the data from department. Let me delete the data from my department. Now, what I will do is, I will actually I'll just use the same transaction as that of the parent transaction. Now, what I'll do is now you see here, run as Java application. Now, if I run this, if you see here, transaction rolled back because it has been marked as rollback only, because it is because now both employee service and department service are using the same transaction. So if employee service is throwing the exception out of this method, so that means this transaction is set to roll back. And since department service is also using the same transaction, though it is catching the exception here, but employee service is using the same transaction of department service, and employee service is throwing the exception. So that means what is happening, so the transaction which is being used by department, the create department method also is set to roll back. And here you cannot see anything, you cannot see any data. See, you cannot see my department data, or you cannot see my employee data. Okay, now for example, if I'm catching the exception here, I'm not throwing now, I'm catching the exception here itself. So if I don't throw the exception outside the method, so then transaction is not set to roll back. Okay, I'm catching the exception here. So I'm just printing the stack trace of the exception. Now let me run this program again. Now let me run this. Now if you see, let me run this. So select star from my department. So department data is inserted and employee data also is inserted. That means I'm not throwing the exception out of the method, I'm catching the exception internally so that the transaction is not set to roll back. So I think so this is how transactional propagation works. And so using the proxy based approach, so if I want to call a inner method from the outer method, where the outer method is in one transaction, and the inner method has to be controlled in another transaction, so I cannot call the inner method from the same class, because as I told, the inner method will not be intercepted by the proxy. So the inner method, to intercept it from the inner method has to be called from another service. So another service, whenever I call the inner method from the another service, that service will be intercepted by proxy, and transaction logic is applied in that way. So with this, this is the end of the lecture. So I will be explaining about few other concepts in upcoming videos. Thank you for listening.